Okay, this is your chapter review for your chapter 14 test tomorrow. All right, we're going to be working problems very similar to what you would see on your test. All right, I want you to write the product as a power. We'll go 7s and X's and Y's. Okay, you're simply writing the product as a power. Else, what's going to be?
7 to the 4th power, x to the 3rd power, and 1 to the 4th power.
Okay, very good. And we don't have any dots in between the terms, so that's just one thing we want to make sure we don't do. Sorry, I had to kind of squish it in there. We just want to write them all together like that, showing multiplication. All right, number 2, this is going to be another section where it just says use the properties of exponents to simplify. So I'm going to do the one that I've seen the most confusion kind of happening. If I had 6x to the 5th power over 30x to the 2nd power. All right, and I said you need to simplify this expression using your properties of exponents. All right, go ahead and do that one. All right, what would you do first? What would you do first, Isaiah?
You gotta combine the x's.
You do have to combine the x's. Can you do anything with those numbers right there?
Oh, reduce it.
Can you reduce 6 over 30?
Yes.
What can you reduce it to?
1/5.
1/5, right? And then he's right that I need to combine my x's. Remember, it's the numerator minus the denominator. Basically, what I'm doing is I'm bringing them up into my numerator to subtract them. All right? So what is 5 minus 2?
3.
X to the 3rd power over 5. Now, can x to the 3rd power stay in my numerator, or do I need to move it to the opposite side of the fraction? How do I know it can stay? Right? Because this is a positive exponent. I don't have to move it. If I had subtracted these, Kayla, if I had subtracted these and it had been a negative number, then I would move it. Okay, so that's how I know. All right, let's do another one. All right, so this one's kind of a breath of fresh air, hopefully. Okay, what if I told you to evaluate negative 7 squared and to evaluate negative 9 squared? Caden, what is negative 7 squared the way that I have it written up here on the screen? Okay, he says it's negative 49 because what is it missing?
Parentheses.
It's missing parentheses. If it had parentheses, the base would be negative. But because it's not, I evaluate the exponent and my answer is negative every time. Kayla, what's number 4? It's positive 81 this time because the negative 9 parentheses means negative 9 times negative 9. What if, okay, so this one was kind of tough on the quiz. What if I had 5 to the 9th power x to the 4th power over 5 to the 6th power and x to the 10th power? And I said, simplify the expression. And what I mean by simplify the expression, you cannot have negative exponents in your answer. All right, so you need to simplify it as much as you can and make sure there's no negative exponents in your answer. Okay, Jamie, when you simplified your 5s, what did you get when you Yes, very good. So what she did was she subtracted the 6 from the 9. Does everybody agree 9 minus 6 is 3, right?
Yes.
Positive 3. So it's 5 to the 3rd power. And Caden, what did you get when you subtracted your x's? Yes, x to the negative 6th power. All right, so there's a couple things here. Now, everything's in the numerator now. I subtracted everything into the numerator. Can everything stay in the numerator?
No.
What needs to move back to the denominator?
Negative 6.
The one with the negative exponent, the whole term, okay? So 5 to the third can stay on top, and x to the 6th moves to the bottom. This is your half credit answer. Why is this not full credit?
Because you gotta evaluate.
Yes, 5 to the third power. So that's one part that some people forgot to do on their quiz. 125 over x to the 6th power. Okay. All right, so that's good on that one. Here's another one that was really commonly missed, okay? It's one that looks like this, and I'm going to kind of try to mirror it a little bit with your quiz, your test question. Let's say it's x to the third power over, we'll go 2x to the 4th power. Okay, so what I want you to do, again, is simplify the expression. Okay, so here's what I need you to understand, guys. This is not 2x to the 4th power. If it was 2x to the 4th power, it wouldn't need parentheses. What do the parentheses mean, Isaiah?
You have to multiply you actually do like 2 to the 4th power.
Yes. This means 2 to the 4th power and x to the 4th power. Okay, so this is x to the 3rd power over, what is 2 times 2 times 2 times 2? 16 x to the 4th power. Now I'm ready to simplify any exponents that have a common base. Do I have any exponents that have a common base? Yes, my x's. So x, remember I do numerator minus denominator, and I keep the 16 on the bottom. What's 3 minus 4?
-1.
Okay. Yes, but I got to move it to the bottom.
So is it 1? Okay, yes.
1 over 16x. Okay.
Put the 1 to the 1st power?
1, or the x to the 1st power? Yeah, I mean, that's fine. All right. Let's see here. Let's do one of these. Let's say we have 10 g. No, we'll do f. 10f to the negative 4th power over 5f to the negative 6th power. And I want you to simplify this and make sure you write your answer using only positive exponents. Okay, so 10 over 5 reduces to what? 2 over 1. We'll keep it over 1 for now. And then remember, f to the negative 4. And guys, the people who wrote this got it right. The people who skipped this step, some of them missed it. And I really think that you will get it right if you just write this step. You have to subtract the denominator. So when you show that, it's obvious that what happens? Double negative. So negative 4 plus 6 is what? So 2f to the positive 2nd power. Now, do I need to do anything here to rewrite anything? No. I'm just done. Okay, and you don't even have to put it over 1. Okay, all right. Now, scientific notation. I think we're good here, but I am going to just give you a couple real quick. 120, we'll go billion. All right, and then we'll go the other way, and we'll say okay, go ahead and write these two numbers in scientific notation. So let's say the first one together. 1.2 times 10 to the 11th power. All right, let's say the next one. 7.28 times 10 to the negative 6th power. That's what people missed. If they missed anything at all in this section, they missed that the really, really small numbers have to be written with a negative exponent. All right, let's go the other way. Number 10. Okay, standard form. So let's say I have 3.625 times 10 to the 8th power, and we'll go 6.42 times 10 to the negative 4th power. All right, go ahead and write these two numbers in standard form. Okay, so someone raise your hand and tell me how many zeros do you need to put into that number, and where would they go?
5 and behind the 5.
Raise your hand, Miles.
5 and behind the 5.
Yes. So what we're doing here, okay, so write out all the numbers first, okay? And what we're doing here, 1, 2, 3, 4, and 5, is we're moving the decimal. You don't have to write this part. But the decimal was here, and we're expanding it by 8 decimal places, okay? I knew that I already had 3 numbers, so I needed 5 more zeros to get me out 8 decimal places. So it's understood, but your decimal's here now. So what needs to go every 3 places from right to left? A comma. 1 comma here and here. Okay, so make sure you have the commas and understand that the decimal has been moved out of the number. All right, how many zeros for number 11, and where do they go? Anybody? How many zeros and where would they go? Caden? Okay, so how many zeros before the 6? Yep, 1, 2, 3. And 6, 4, 2. All right, because I'm moving the other direction, this 1 digit counts as 1 0, so I need 3 more zeros in front of the 6 to move it out 4 decimal places to make it a really, really small number. How did I know it was going to be a really, really small number?
Because it was a negative.
The negative exponent. All right, now you have 4 questions on your test that deal with these operations in scientific notation. You must keep the answers in scientific notation. I've been giving a little bit of partial credit if you actually solve these, but please do not do that. You won't get any credit on your test. All right, so I'm going to do some of the, I would say, more challenging ones. All right, 8.3 times 10 to the 4th power plus 4.2 times 10 to the 2nd power. All right, you might want to write down this original problem because you'll need to kind of reference it to solve. So first of all, what operation is happening here? Which of the 4?
Adding.
How do I know I'm adding? Okay. What is step 1? If I know it's addition, what is the first thing I need to do?
Common exponents.
Yeah, common exponents.
Common exponents, right, guys? Do I have common exponents?
No.
All right, so which one do I leave the same? Tell me which one I leave the same, first one or the second one?
First one.
All right, so the first one I leave the same because it has the larger exponent. The second one, how many exponent values do I need to increase it by? 2, so I need to add 2. If I'm adding 2, what is happening to my decimal point?
You take a left decimal left.
Yes, I go left 2. So now instead of it being 4.2, I can go 1, 2, and I know I need a 0 to hold that place. So now it's 0.042 times 10 to the 4th. All right, I did all of that to make sure that I had common exponents. Now what can I do? Just add the numbers together. Line up your decimals. 8.3 plus 0.042. And then your 0 placeholders. For addition, it doesn't matter too much. So 8.342. Now, do I need to add my exponents together for my tens?
No.
No. Bring down the common exponent. With addition and subtraction, I bring down the common exponent. I do not add them together. When would I add them together? What operation? Multiplication, okay? So let's do number 13. We're going to do 2 more. Number 13, I'm going to say 7 times 10 to the 5th power times 6 times 10 to the 7th power. All right, go ahead and evaluate this expression. Make sure you leave your answer in scientific notation. Hey, what do I do, Isaiah? What do I do first? 7 times 6, 42. And what can I do? Oh gosh, that was a little aggressive. What can I do with my powers of 10? Because it's multiplication. Jamie, what can I do? Yes, I can add them. And what would I get? Yes, very good. 10 to the 12th power. All right, great. This is my final answer. I'm done. Jamie's shaking her head. Why? Yeah, 42 is too big. So where do I need my decimal to be? Where would my decimal be? Okay, so it needs to move left 1 place to make it 4.2. What happens to my exponent when I move my decimal left? It goes up by 1. Did you guys catch it? Okay, yes. If that might be what you did wrong on the quiz, okay? Let's do a division one now. All right, let's do a division one. So we're going to go 2.1 times 10 to the 9th power divided by let's see. Okay, 7 times 10 to the 6th power. Okay, so the first number goes on the inside. The second number goes on the outside. Does 7 go into 2? Nope. Does 7 go into 21? Yes, so 0.3 times 10. And since it's division, what happens to my exponents? Subtract. Okay, great. This is my final answer. No, why? Because my number's too tiny. My number's too tiny. So which way does my decimal have to move now? To the right. Okay. So now my exponent value goes down 10 to the 2nd power. All right, guys. I did have it kind of in the plan to put some review questions from chapter 13, but I do not have those on your test. This is your test. It's a 25-question test, and we've pretty much covered. You can see we did 14 problems, but we might have just done one problem from the same section, but just kind of focus on maybe one of the more difficult problems. But you really should be ready for your test tomorrow.